Okay, so when we draw trig equations, so say for example a sine graph, we know that within a 2 pi or 360 degree range, there are two solutions for any particular value. So we also know that that's not the end of the matter. If I was to draw the graph on my calculator, I could find solutions by drawing a line with the equation and finding out where those two things meet. If I just use sine, cos or tan on my calculator, it just gives me the first answer. But obviously we know that all trig graphs repeat infinitely in both positive and negative directions on the x-axis. Therefore it makes sense that there are an infinite number of solutions unless we specify a range. So if I'm given a range, say between 0 and 2 pi, then I know the number of solutions I've got. However, if that range is infinite, then there's an infinite number of solutions. So we have a formula for the general solutions of trig equations. And they're these. They're on your formula sheet, so you don't need to remember them. There are 3 easy step rules to remember how to work out and solve a general solution for an equation. And here they are. Number 1, solve the equation as you would normally to find your first value, which we call alpha. Then stop as soon as you've done inverse sine, cos or tan on your calculator. And you'll see why that is when you do some examples later on. Once I've done that, I substitute that value of alpha into the appropriate equation. By that I mean whether it's sine, cos or tan from the 3 that you're given above. And I'll explain in a minute what those things do. So, here's an example, a nice easy example. 3 cos x equals negative 2 is an equation, and we're asked to find a formula for the general solution. So just like you would solve a normal equation, first thing I'm going to do is divide by 3. So I've now got cos x equals negative 2 over 3. The next step I would do is to inverse cos, which gives me x equals 2.3005. Notice I'm working in radians. Now, my first instruction said stop. My second instruction said stop as soon as I've found inverse sine, cos or tan, which I've just done. So I'm going to stop. Now what I'm going to do is I'm going to look at my general solutions and find the equation at the top for theta. Instead of theta, I'm going to write x, because that's what I've got on my left. So I've got x equals 2n pi plus or minus alpha. Now alpha is the angle I've just calculated, which is 2.3005. So there's the answer. That's all I need to do. That is the general solution for that possible equation. But what does it mean? Well, n is any integer. So in other words, if I substitute in different values of n, I will get different possible solutions for that equation. So for example, if I say n is 0, then the whole first section, 2n pi, becomes 0, and I'm left with either x is 2.3005, or of course x is negative from that equation there, 2.3005. Remember, those two angles are in radians. So then I can look at what happens if n is 1. So if n is 1, I could get 2n pi, so that's 2 times 1 times pi, which is 6.2 something or other, plus or minus my 2.3. So that gives me two possible solutions of 8.584, or the other possible solution is 3.98. If you don't believe me, try those calculations on your calculator. So 2 times n, 1 times pi, plus or minus, etc. The other thing you can do now is go onto your calculator, type for first equation 3 cos x, second equation negative 2, draw the graph of those two functions and find out all the places of intercept, and don't give yourself a specific range. Go, say, between 0 and 20, working in pi, working in radians. 0 to 20 is a large amount of angles, so you'll get quite a few graphs repeating themselves, but if you look at all the intersections, you'll see what I mean. The ones we've given here will start to appear. Obviously, if you want to include the negative ones, you need to include negative values. But the idea is that no matter what value of n you substitute any integer in there, it will give you all the infinite number of possible solutions to that equation within an infinite range. As I said before, if we specify our range, then we don't have general solutions, we have a specific number.